discussing the different vocabulary surrounding it, and why is it that we're even studying it. Now, you have your calculators with you. If I'm going to type, like, this should be in the radian measure because our angles are in radian. So if you will type cosine 2 pi over 3, 2 pi over 3, that's 2 pi over 3, you would see that the value is negative 0.5. And as we know that if our angle is 2 pi over 3 and we're looking for cosine, all we need to do is to find the x value here, which is negative 1/2, and the calculator gives us the answer. It's because during our time, all right, we don't have this kind of sophistication when it comes to calculators. We don't have scientific calculators. We only refer to the unit circle to find the measures of our trigonometric functions. And these are actually the exact value, and the calculator is giving you only values from 0 to 90. It doesn't give you the values from 0 to 360. So therefore, to find what is the measure of this, we need to refer to the reference angle here. So what is a reference angle? So these are called the reference angle. At the same time, in our time, we also call them the special angles. And special angles are supposed to be acute angles from 0 to 90 that contains a special triangle. Okay? So these are measures of the special triangles, and these are 30, 45, and 60. And in radian measures pi over 6, pi over 4, and pi over 3. The reason why they are like that, because pi is always equivalent to 180 degrees. So 180 divided by 3 is 60, and so on. All right. The other types of angles that you can find here, actually there are 3, are the quadrantal angles. And the quadrantal angles are names as such because they contain the coordinate axis of the coordinate plane. So therefore, we refer to 0 degree. Okay, we refer to 90 degrees or pi over 2. Okay, and then we refer to 180 degrees or pi. And we refer to 2 pi or 360 degrees. So these are called quadrantal angles. So before, when they asked me, what is the value of tangent 90 degrees? I know that tangent is y over x, and y is 1 and x is 0. So I would know that tangent 90 is undefined because there is no way for me to find it using a calculator because we don't have it. We just have the unit circle. All right, so now, the other angles that you can see here are the coterminal angles. Okay? From the word itself, coterminal, it means that they have the same terminal side with the reference angle, which are this. Okay? Meaning to say that they will terminate at the same side. So you have two parts of an angle in a unit circle. We have the initial side, and usually the positive x-axis is our initial side, and our terminal side, which could land in any of our coterminal angles. Going in a clockwise direction is positive, so from here to here is a positive angle, and going in a clockwise direction, that's counterclockwise, and then clockwise direction is a negative angle. Now, let's say for example, I would like to find what is cosine 5 pi over 6. Okay, then of course, we know that it's the same as 150 degrees. Its reference angle is 30 degrees, meaning to say it has the same absolute value as the value of cosine 30. And cosine 30 is the square root of 3 over 2. And our cosine pi over 6 is negative square root of 3 over 2. Now, why is this positive? Why is this negative? Now, remember, in a coordinate plane, the x value is negative, and we know that cosine is x, and y is sine. Okay? And so, therefore, the x value here is negative, so therefore, the value of cosine is negative. Another good example, let's say, for example, I'd like to find what is sine, okay, 5 pi over 4. And 5 pi over 4 is 225 degrees. And to find its coterminal angle is to find its reference angle here. And that's 180, 225 minus 180, which is 45 degrees. And so we can refer to 45 degrees here. Alright, and sine 5 pi over 3 is square root of 2 over 2. And so therefore, sine 5 pi over 4 is also square root of 2 over 2, but it is negative because it is not in its territory. It's tangent, that's positive here. Here is sine, here is all, and here is cosine. So therefore, since sine is not in its proper position, it's gonna be negative. Now, we call this memorizing the signs of our coordinate of our circular function as ASTC plus. That means in the first quadrant, all functions are positive. In the second quadrant, only sine and its reciprocal, cosecant, and tangent in the third quadrant, and cosine in the fourth quadrant, including secant. If they are not in their territory, they will be negative. So that's how we understand everything about what a unit circle will be. And all of these actually can circulate around values in your calculator. Just find out what are the decimal values of your point. I'm going to give you like a good example using verification of coterminal angles without referring to that. Let's say, for example, I have an angle which measures 135 degrees. And I wanted to find what is sine 135 degrees. And I don't have a calculator, so what I can do here is to draw it from here to here. So that's probably 135 degrees. And so to find 135, because I only know from 0 to 90, we have a trigonometric table from 0 to 90, I will need to find its reference angle. And we can do that by 180 minus 135, which is 45 degrees, which means that the value of sine 45 degrees is just the same as the absolute value of sine 135 degrees, because this could be negative, but because you are on the second quadrant and in ASTC plus, this will be also positive. And because this is 45 degrees, we know that it will terminate at the point negative square root of 2 over 2 and square root of 2 over 2. So therefore, the value of sine 135 is square root of 2 over 2. But of course, that would be if the calculator is not existing. Now, if you're going to type sine 135 here, okay, and it's not in degrees, so we can change the mode. You see it's 0.707, and if I'm going to find the value of square root of 2 over 2, you will see that they would be the same. So, I'm just saying that everything, all the things we have in our calculator circulates around the idea of a unit circle. And also, in the unit circle, all the values around here are the values of sine and cosine. Okay, however small or however big your angle is, the values of your sine and cosine surrounds the unit circle.